The next AI data center might not be built in Nevada. It could be orbiting above it. This video is about the push to put data centers in space, and the point is simple. AI's real bottleneck is no longer talent or ideas. It's power, land, and chips. As those constraints harden, the cloud is starting to look up, literally, and serious players are testing whether orbital compute is cheaper, faster, or cleaner at scale. AI demand is exploding faster than utilities can add new megawatts, and grid interconnection queues now stretch years in major markets. Local moratoriums, transformer shortages, and substation scarcity are turning ground real estate into the new scarcity. When the constraint is watts and permits, moving compute to where the energy is, space, stops sounding like sci-fi and starts sounding like strategy. In Europe, Thales Alenia Space leads Ascend, a study on orbiting data center modules powered by continuous solar, with optical lasers beaming data back to Earth. On the ISS, HPE's spaceborne computer has already run standard servers in orbit for years, proving you can do real workloads off-planet. Startups like Lone Star want off-Earth storage on lunar landers, and defense missions already run AI inference on satellites to filter imagery before downlink. The mechanism is straightforward. Orbit offers 24/7 sunlight in certain paths, no zoning fights, and a vacuum that enables large radiators for heat rejection, though thermal design in space is tricky without air. Optical links now push hundreds of gigabits per second. NASA's T-Bird hit 200 Gbps, so downlink isn't science fiction. The frictions are real. Launch mass is expensive, radiation hardening or shielding is needed, datasets are petabyte scale to upload, and latency jumps from sub-5 ms on a metro fiber to tens of milliseconds in LEO and 600 ms in GEO. Near term, the viable play isn't training GPT-10 in orbit, it's edge compute for spaceborne data, secure cold storage, and specialized AI inference that benefits from constant power. Expect orbital testbeds where cloud providers, primes, and agencies trial GPU-class accelerators in LEO using optical downlinks to stitch results into Earth networks. Chip vendors will experiment with shielded, low-power accelerators built for radiation and tight thermal envelopes. If this works even at modest scale, the center of gravity in AI shifts toward whoever controls launch, in-space assembly, and optical comms, not just who writes the best model code. ESG math could tilt too. 24/7 solar in orbit looks green on a dashboard, forcing regulators to count launch emissions and debris risk in the life cycle. It also creates a sovereignty lever. Space-based cloud nodes become national infrastructure, not just another region in a pricing menu. Here's the shift. We're leaving the era where algorithms decide winners and entering the era where watts, land, and logistics do, and the cloud expands to any place with energy and permission. Space is simply the purest version of that logic. Move compute to energy, not energy to compute. The companies that win will vertically integrate the stack from power to placement to packet, on Earth and off it. In the next 3-6 months, you'll see at least one major cloud or integrator announce an on-orbit AI inference pilot with a space prime, with optical downlink to a terrestrial region. Utilities will ink more dedicated gigawatt deals for AI campuses, and grid delays will push governments to fast-track energy-adjacent zoning, making off-planet options look comparatively cleaner and faster on a board slide. Over 12-18 months, two strategies will go head-to-head. Terrestrial megacampuses anchored to nuclear and renewables with immersion cooling, and orbital prototypes proving steady-state operations with shielded accelerators. Expect a first-pass cost curve comparing Thales TF light hour in orbit versus on Earth, and at least one sovereign cloud to pre-buy launch capacity for space region trials aimed at secure workloads and constant power jobs. If you want the next signal before it turns obvious, subscribe to Future Signals and watch the next breakdown.